Okay, so now we're gonna start actually solving a lot of questions because we're done with what we need to finish for Unit 1 of algebra, number and algebra. Of course, there's still some topics left, very important ones as well, like proofs, like the rest of proofs. There's also complex numbers, the extension of binomial theorem. But for now, we're gonna focus on these ones. Okay, so I'm using the Math HL Analysis and Approaches book from Oxford. Yeah, it has some pretty good examples and so on, so I'm going to use those. So we're going to look at example 6 here first. It says the fourth term of an arithmetic sequence is 18, and the common difference is -5. Determine the first term and the nth term. Okay, so we're going to switch over to here so we don't see the answers and work it out. So it's given to us that the fourth term is 18 and that the common difference is -5. We need to find u1 and un, the nth term. Okay? Okay, cool. So let's first of all start off by trying to find u1. So what is our equation or formula, right? Our formula is un is equal to u1 plus n minus 1, right, times d. Okay? So what do we have? We have d. We can replace un using u4, right? And that's going to give us n. And then that's just going to leave this unknown variable u1, and then we can solve for it, right? So let's just go ahead and do that. So we're going to sub in u4 in this equation. So we're going to have still u1 plus 4 minus 1 times -5, yeah? So u4 is equal to what? u4 is 18. So that means 18 is equal to u1 plus, and then it's going to be 3 times -5. So actually minus 15. Minus 15. Yeah. Now if we put the 15 on this side, it's going to give us that u1 is equal to 33. So since u1 is equal to 33, now we can work out for the nth term. So we have the nth term is going to be un is equal to u1, which is 33, plus n minus 1, right? We don't have an n in this case, times -5. Okay, so now this is not the simplest form that we can leave it in, so we're just going to simplify even further. So you have 33 plus, and we're going to expand these brackets. So -5 times n is going to be minus 5n, and then -1 times 5 is going to be plus 5, right? And then we can simplify it further. We can add the 5 and 33. It's going to give us 38 minus 5n, and that is the general term. So these are our two solutions. We have u1 is equal to 33 and un is equal to 38 minus 5n. Let's check our answer. So u1 is equal to 33, un is equal to 38 minus 5n. That is correct. Okay, let's move on to the next question. Okay, so now let's move on to the next question. So we have example 7. Find the number of terms in the following arithmetic sequences. Okay, so find the number of terms in the following arithmetic sequence. Let's write down the first one. So 20, 23, 26, 83. So 20, 23, 26, dot, 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 83, I believe. Yes. Okay, cool. So first of all, we know that the nth term un, if it's a finite sequence, then un is going to be the final term, right? So we know that un is equal to 83. We also know that u1 is equal to 20, right? Now, what is the common difference? Yeah, we don't know the common difference, but we can easily get that by, looking at these consecutive terms. We can do 23 minus 20. It's 23 minus 20. I'm going to get what? 3, right? You can also do 26 minus 23. So 26 minus 23, that's also going to give me 3. So the common difference here very clearly is equal to 3. Okay? So that's the first thing to keep in mind. So we have these three variables. Now, using this formula, un is equal to u1 plus n minus 1 times d, I can find the number of terms by looking for n. Okay? So this is how I do it. First of all, you're going to plug all of these variables into un. Yeah? So you're going to have un is equal to u20, u1, which is 20, plus n minus 1 times 3, right? So that's going to give me what? 20 plus 3 times n is 3n. 3 times -3 is not minus 3. That's going to be 17 plus 3n, right? Because 20 minus 3. Now, I have un, and then here, un we're given is 83, right? So this is 83. So now I have n, which is the only unknown variable, which now I'm going to solve for. So 83 minus 17 is going to be 66, right? Is equal to 3n. And then if you divide both sides by 3, you're going to get n is equal to 22. Okay, so this is how many terms is in this sequence. There are 22 terms in this given sequence. Okay, cool. Let's move on to the next one. 34, 30, 26, 34, sorry, 34, 30, 26, and what's the last term? Negative 30. So dot, 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 negative 30. Okay, so in this question, we can actually see that the sequences are descending. Yeah, so there is going from 34 and then it ends in negative 30, right? So first of all, un is negative 30. We know that u1 is equal to 34. And we know that d is going to be some negative number, right? Because the sequence is descending. So what is it? We can subtract 30 from 34. So 30 minus 34, that's going to give me what? Negative 4. Or we can say 26 minus 30 is going to equal to what? Negative 4. They're both the same, yeah? So for our common difference here, we have negative 4. Cool. So now let's work out for the nth term, just like we did for the first one. So for this, we're going to say un is equal to 34 plus n minus 1 multiplied by negative 4, right? This is going to give us what? 34 minus 4n plus 4. Yes? That's going to give me 38 minus 4n. Okay, now what is un? Un is negative 30, so I can say negative 30, negative 30. So now I'm I'm subtracting 38 from 30, negative 30. So let's say just 30, 38, that's going to be 68. So negative 68 is equal to negative 4n. Yeah, now 4 times what is going to give me negative 68? Let's see, that's divided by 4 is 17. So 17 is equal to n. Yeah, so n is equal to 17. Okay, cool. Let's just check that we have these correct. So we have 22 and 17. Good. Now the last one. Last one says 6a, 4a, 2a, 6a, 4a, 2a, dot, dot, dot. And then the final term is negative 22a. Negative 22a. Okay, good. So, we're dealing with an unknown variable here. For some reason, they have a, but we don't let that stop us. Don't let it also scare you or whatever. It's probably going to be an easy solution. So you have u1 is equal to 6a, right? And then you have un is equal to negative 22a. And then the common difference, right? Again, the common difference I can take by doing this minus that. So 4a minus 6a is going to be negative 2. Same thing with 2a minus 4a is going to give me what? Negative 2. A and a, sorry. So the common difference is negative 2a. Okay, so negative 2a. Good. So now let's build the formula. So un is equal to 6a minus n minus 1 times negative 2a, right? So let's expand. We have 6a minus, sorry, this is supposed to be plus. Well, it's going to be minus now. Negative 2a times n is going to be negative 2an, right? And negative 1 times this is going to be plus 2a, right? So un is equal to negative 22a. I'm going to do it like this. So now 6a plus 2a is going to be 8a minus 2an, right? Then we're going to subtract negative 8, so we're going to subtract 8, sorry. So it's going to be negative 30a. And then is equal to the negative 2an. So we'll divide both sides by negative 2a, right? So these two will cancel. You have n left alone. And then negative 30 divided by negative 2 is going to be 15, and a will cancel out. So you have n is equal to 15. So that's how you do this question. Okay, let's move to the next one. Okay, so now the next question It says here, this is the question, by the way. So the three numbers are consecutive terms of an arithmetic sequence. The sum of the three numbers is 45 and their product is 3,240. Find the three numbers. Okay. So we know that we have an arithmetic sequence, three consecutive terms in an arithmetic sequence. We know the sum, which is 45, and the product is 3,240. Okay? So from this, what do? First of all, we need to model our three numbers. Yeah, we need to give them like some names. Yeah. So we're gonna model them by the definition of an arithmetic sequence. So let's say you have the term u. So now you're gonna have a term before u and a term after u. So the term after u is u plus the common difference d, right? And the term before is going to be u minus the common difference d. So these are my three terms of the arithmetic sequence. Okay? Okay, good. So now this term plus this term plus this term should give me 45. And this term multiplied by this one and this one should give me 3,240. So what are we going to do? We're going to build these equations. So we're going to add all of these together. So let's say you have u minus d plus u plus u plus d. Okay? So in this case, let's just start adding all the common terms. So you have u plus u plus u. So u plus u plus u. And then you have minus d plus d. And then that equals to 45, right? Cool. So u plus u plus u is 3u. And then negative d plus d cancel out because it's just, yeah, 0. And that will equal to 45, right? So you have 3u is equal to 45. So we're going to divide both sides by 3. These two cancel, so you have u is equal to 45 divided by 3, which is 15. So you already found u, and that is 15. So you found the middle term, okay? Now what we're going to focus on is to try to maybe find what the value of d is. What is the common difference, okay? Cool. So we're going to use the second equation now. So you have u minus d, right, multiplied by u plus d, yeah? So, and this should give us 3,240. Cool. So let's start multiplying. Let's do these two terms first. So u minus d multiplied by u plus d. Okay. So what is this going to equal to? U and u is u squared, right? Negative d and u is negative du. Sorry, this is an incorrect way to go about it. So u and u is u squared. U and d is plus ud. And then negative d times u is negative ud. And then negative d times d is negative d squared, right? So these two cancel out, ud minus ud, so this just goes away. And then now we have u squared minus d squared, yeah? So this is the term when you multiply these two together. So of course we still have a u here in the middle. So we're just going to say u multiplied by u squared minus d squared. Now, we could expand u here, but that's just going to make it complicated, yeah, for no reason, because now we're going to have a cubic function. It's going to be u cubed minus d squared u, yeah, or ud squared, which is not the greatest. So we're just going to equate this to 3,240, and now we're just going to solve, because we have u, right? So what can we do? First of all, I'm going to divide this side by u. Yeah, I'm going to divide it by u, so these two will cancel out, right? And this side will be divided by u. So that's going to leave us with u squared minus d squared is equal to 3,240 divided by u, right? And that is 3,240 divided by 15. Okay, good. So u squared is going to be 15 squared, right? Which is 225. So I'll just write that right away. So 225 minus d squared is going to equal to 3,240 divided by 15. So let's see what that is. That is 216. So you have 260, right? And now you'll say minus 225 from both sides. So you say minus 225 minus 225. Yeah. So and then you're going to get negative d squared is equal to 216 minus 225. So of course, we're not in favor of all of these negatives, so we're just going to multiply the whole equation by negative 1. This is going to give me 2 squared is equal to negative 216 plus 225. Okay, so d squared, therefore, is going to be negative 216 plus 225, which is 9. Of course, we're going to take the square root for both sides. So d is equal to plus or minus 3. Yeah? So now we found d. So d is plus or minus 3. So now we can actually take this information and refer back to our term over here and apply it to our three terms of the arithmetic sequence. So if u is equal to 15 and d is equal to plus or minus 3, right? Then I have the term in the middle, and then this term before it is u minus d, and the term after it is u plus d, right? So I have 15 in the middle. U minus d is going to be 12, and then u plus d is going to be 18. So these are my three consecutive terms in my arithmetic sequence. And we can actually even double check by adding them all together. So you can say 12 plus 15 plus 18, and this is going to give us 12 plus 15 plus 18. It is indeed going to give us 45, and therefore 12 times 15 times 18 is equal to 12 times 18 times 15 is going to be 3,240, therefore checked and proved. Good. Nice. Let's move on to the next question. Okay, so now we're going to move on to example 9 over here. The second term of an arithmetic sequence is 20, and the seventh term is 55. Find the first term and the common difference of the sequence. Okay, so we know that the second term is equal to 20, and that the seventh term is equal to 55, right? Okay, so it tells us to find the first term of the sequence and the common difference. Now we know from what we studied in arithmetic sequences, or in arithmetic sequences, that the primary elements that you need are u1 and d. So you need the first term and the common difference to actually do much of anything, right? But in this case, we're given two separate values, right? Which we can plug into this equation right here, right? So that when you guys see something like that, when we're thinking, okay, we need to find two unknown variables, but we have a formula for it, which we can plug two values into. What that should, like, automatically in your head, you should always think, okay, system of equations. Yeah? Because you're gonna have, if you put this into this formula right here, you're gonna have un, you're gonna have n minus 1, what it is, but you're not gonna have u1 and d. And it's gonna be the same thing for when you plug this value in. So you're gonna have two formulas with two unknown variables in each, which then you can put in a system of equations and then solve for u1 and d. Okay? So let's first off set up the equation. So first off, u2 is equal to u1 plus n minus 1, which is 2 minus 1 times d, right? u2 is equal to 20, so it's 20 equals u1 plus d, right? Because 1 times d is d, right? So this makes sense, right? 20, which is u2, is u1 plus d. So u1 plus the common difference equals the second term. So that makes sense. Cool. So this is our first equation. Now the second one. So you plug u7 is equal to u1 plus n minus 1 times d, right? u7 is 55 is equal to, sorry, you're supposed to be 7 minus 1. So this is going to be u1 plus 6d, right? Cool, so this is our second equation. So now let's do it. System of equations. So we say 55 is equal to u1 plus 6 multiplied by d. 20 is equal to u1 plus d. So let's remember when we did simultaneous equations, a system of equations with a 2 by 2 system, right? So this is a 2 by 2. So you can do the substitution or the elimination method, right? So in this case, we can do the elimination method, and we actually don't even have to do much because we have u1 and u1, and this is 6d and d, so these two are different, right? But these two are the exact same. So if we just subtract both equations from each other, we're going to be able to get rid of u1, yeah? Which leaves us to solve for d, okay? So then we're going to have 55 minus 20, which is 35, is equal to 6d minus d is 5d, right? So therefore, d is equal to 7, right? Because 35 divided by 5 is 7. Cool. So now that you have that, take it and plug it into whichever equation you want. I want to plug it into equation number 2, Okay, so I'm going to take D7 and plug it into 2. We have 20 is equal to U1 plus 7. Okay, we're going to do minus 7, so 13 is equal to U1. So let's check this information. If U1 is equal to 13, right, and D is equal to 7, and the second term is equal to 20, that makes sense, right? Because 13 plus 7 is equal to 20. There we go. It is done. That question is now done as well. Okay, let's move on to the next one. Okay, so let's move on to this example here. This one tests our knowledge on the sum of an arithmetic sequence. So the first term of an arithmetic series is 5, and the last term is negative 51. The series has 15 terms. Find the common difference, the sum of the series. Okay, so the first term, okay, it says that u1 is equal to 5, okay, and that the last term un is equal to negative 51. Yeah. It says that the sequence has 15 terms, which means the last term is actually then U15. So U15 is negative 51. Yeah, so these two are just basically the same. So we're supposed to find the common difference and the sum of the series. Okay, so we can use this formula right here for arithmetic sequences, right, to find the common difference. We're going to have U15 is equal to U1, which is 5, plus 15 minus 1 times D, right? So U15 is equal to negative 51 is equal to 5 plus 14D. So we're gonna minus 5 from both sides, subtract 5 from both sides. So we're gonna have negative 56 is equal to 14D, right? And then you're gonna divide both sides by 14. So negative 56 divided by 14 is equal to 4. Yeah, so D is equal to 4. Let's double check that. Negative 4. Ah, yes, sorry, negative 4. So negative 56 divided by 14 is D is equal to negative 4. So this is the common difference, right? So now, we have to then find the sum of the series. So if you remember, there were two equations to find the sum of an arithmetic series. You have n over 2 multiplied by u1 plus un, right? And then you had another one where it's n over 2 multiplied by 2u1 plus n minus 1 times d close bracket, yeah? So in this case, this is when you had u1 and un, and this is where you had u1 and d, right? So in this case, we're going to use, or we have u1 and un, yeah? So therefore, we're going to use this formula right here, okay? So that's the formula we're using. S15, because it's 15 terms, is equal to 15 divided by 2 multiplied by u1, which is 5, plus negative 51, so minus 51. Yeah, minus 51. Okay, so S15 is equal to 5 minus 51 is going to be negative 46, so 15 over 2 multiplied by negative 46, and let's multiply that now. So we have 15 over 2 multiplied by negative 46, and that is negative 345. So the sum, it's not 45, it's 15. So the sum of the 15 terms is equal to negative 345. So let's go ahead and check that here, negative 345. Okay, let's move on to the next question. Okay, so now the next question. Next question says the first term of an arithmetic series is negative 7. So the first term is negative 7. Okay. And the fourth term is 23. So U4 is equal to 23. The sum of the series is 689. So Sn is equal to 689. Find the number of terms in the series. Okay. So we have U1, we don't have UN, we don't have what the final term is. Yeah, the nth term, we don't have what it is. So we're going to need to find the common difference, but we can do that because we have U1 and U4, right? We can use those to and plug them into our equation, our formula. UN is equal to U1 plus n minus 1 times D, right? So we'll plug it in. So we'll say U4 is equal to U1, which is negative 7, plus 4 minus 1 times D, right? U4 is equal to 23, so we're going to say 23 is equal to negative 7 plus 3D, right? So then this is going to be 30 is equal to 3D. Divide both sides by 3. This cancels out. d is going to be 10, right? So d is equal to 10. So now that we have this, we can now solve for this for the question of how many terms is in this sequence using the equation for the sum of an arithmetic sequence, right? So you have Sn is equal to n divided by 2 multiplied by 2u1 minus n, sorry, it's going to be plus n minus 1 times d close bracket. Yeah, so this is the formula, right? So we have Sn. Sn is equal to 689, right? So we're going to say Sn is equal to n divided by 2. These are not given, n is not given. U1 is equal to negative 7, right? So 2 times negative 7 plus n minus 1, again not given, but the common difference is 10, right? And this is all equal to 689. So now let's try to simplify. So n divided by 2, we're going to leave that as is, for now at least. And then 2 times negative 7 is negative 14, plus we're going to then oh my god, what's it called? We're going to expand, or yeah, we're going to expand 10, or this bracket, by 10. So 10 times n is 10, n, and then 10 times negative 1 is minus 10, right? So there you go. Now, we're then going to simplify that even further. So you have 689 divided by, is equal to n divided by 2, multiplied by negative 24 plus 10n. Okay, so now what are we going to do? I would like to multiply both sides by 2 to get rid of this 2 in the fraction over here. So I'm going to multiply here by 2, and here I'm going to multiply by 2. So these 2's are going to cancel. 689, 689 multiplied by 2 is 1,378, is equal to n times negative 24 plus 10n. Okay? So now we expand. 1,378 is equal to negative 24n plus 10n squared. Yeah. And then we're going to subtract negative 1,378 so that we can get it all on one side. So you have, and we're going to rearrange basically. So you have 10n squared minus 24n minus 1,378 is equal to 0. So now you have a quadratic. You can simplify this quadratic even further by dividing by 2, because we know this is 689 times 2, right? And this can also be divided by 2, and that can be divided by 2. So you're going to have 5n squared minus 12n minus 689 is equal to 0. This factors to 5n plus 53 multiplied by n minus 13. Okay, so this is it factorized. So therefore, from the second bracket, we can deduce that n is equal to 13. So the solution, or the amount of terms in this series, is n equals to 13. Okay, let's move on to the next one. Okay, so the next question. Find the value of the sigma notation, and here we have r is equal to 1, 28, and then 5r minus 4 is the expression. Okay, so let's write the sigma notation here. Yeah, so we have this. This is, I believe, 28, and then this is r equals 1, and then we have 5r minus 4. 5r minus 4. So first of all, let's remember what we learned. What does this mean? Okay, so we're supposed to find what, sorry? Find the value of it. Okay, so first of all, we remember that this was what? This was our start. So this is where we're starting. Yeah, and this is where we're stopping. Yeah, this is the expression that we are, or like, yeah, that we're expressing, or like the sequence. No, not the sequence. What was it called? The pattern of the sequence. Okay, so, and the sigma notation basically says that, you know, you're basically summing all of these terms together, right? So you start by r is equal to 1 to plug it into here, and then you're going to keep on going until you reach r is equal to 28, yeah? And after that, you're going to stop, which means r is equal to 28, yeah? R equals to 28 is our final term. And final term is also known as un, the nth term, right? So we have r is equal to 1 is our first term. Yeah, it's u1. So from this, we can find what we need very easily, right? Because the formula for a sum is Sn is equal to n divided by 2, all multiplied by u1 plus un, right? This is the formula for when you have u1 and un. And in this case, we actually have un, right? But we need to work it out first, because you have the expression here. It's not 28, it's 5 times 28 minus 4, okay? So let's work that out. So what is un? Un is equal to 5 times 28 minus 4. Yes. Okay, so 5 times 28 is 140, and 140 minus 4 is 136. So un is equal to 136, and u1 is equal to 1, okay? So using that information, let's plug it into our value. So we have S28, right? Because it's in total 28 terms. So S28 is equal to n divided by 2, so 28 divided by 2, multiplied by 100, is it 1? Yeah, 1 plus 136. Okay, so this is going to be 137. So S28 is equal to 28 divided by 2, which is 14, multiplied by 1 plus 36, which is, yeah, so it is 1 plus 36. I don't know why I'm confused about that. It's just 137. 14 times 137 is equal to S28 is equal to 1,918. Let's double check our answer, 1,918. There we go. Yeah? So that is how you do that. Okay, so now the next question. So it says that the sum of an arithmetic series is given by Sn is equal to n multiplied by 2n minus 3. Okay, so here it says that we're working, so now we can understand that we're working with the sum of an arithmetic series, okay? And that the formula given for the arithmetic, the sum of an arithmetic series is Sn is equal to n times 2n minus 3, okay? That means we cannot use the formulas that are standard to like all sum of arithmetic sequences, right? So we cannot use this one, for example, or we can't use the other one, which is Sn is equal to n divided by 2 multiplied by u1 plus un. Yeah, you can't use these two because it's already given to you. Like for this particular sequence, the sum is found exactly with this formula. Okay, so we need to keep that in mind. But because we're still dealing with the sum of an arithmetic series, we still use the properties of arithmetic series or arithmetic sequences. Okay. So this is the given formula for the sum of a specific arithmetic series which they have given us. We're supposed to find the common difference of that series and the first three terms, okay? So we need D, we don't know what it is, and we need U1, U2, and U3. So let's approach this logically as best we can, okay? So first of all, let's think about it. Let's say, let me draw a random or write a random sequence. So let's say a simple arithmetic sequence. You have 2, 3, 4, 5, 6, and it keeps on going. Okay. If I were to say the sum of the first term, right? So the sum of the first term is going to be 2, right? So that means that the sum of the first term is equal to U1. Right? Yeah, because the sum of the first term is indeed equal to the first term itself. So taking that knowledge and applying it here, I can say the sum of the first term, right? And then plug in the information. So I have 1 times 2 times 1 minus 3. This is going to give me 1 times 2 minus 3, which is 1 times negative 1, which is negative 1, right? So I'm saying here that the sum of the first term is negative 1. And since the sum of the first term is equal to u1, I now know that u1 is equal to negative 1. So this is my first value of like my answer. Yeah. So I have u1 is equal to negative 1. Good. So now let's try to go and find the common difference. Okay. So the common difference, how are we going to find that? Well, we know u1 is equal to negative 1, and this is the equation that they give us. Sn is equal to n times 2n minus 3, right? It's the equation that they give us, and we have u1 is equal to negative 1. Okay, so by definition of a geometric series, yeah, if arithmetic series, sorry. So you have Sn is equal to, and then you have u1 plus u1 plus d, right? And then you have plus u1 plus 2d and then it keeps going on and on and on, right? So that means that the next term, u2, is defined as u1 plus d. Yeah? And we have u1. So therefore, we're going to use that. Okay? We're going to use that definition to our for our question here. So for the sum of two terms, it's going to equal to u1 plus u1 u1 plus d. Okay? So this is the sum of the two terms of this arithmetic series. Okay? So we already know u1, so we're just going to plug it in. So you have s2 is equal to u1, which is -1, plus -1, oops, plus d, right? And close the bracket off. So since you have that now, let's see, let's simplify it as much as we can. Negative minus -1 minus 1 is going to be -2 plus d. Okay, now what are we supposed to do? We have two unknown variables. But hold on, we're given the formula, right, for how to find the sum of the terms, right, certain terms, which means that we can plug 2 into this formula, right? So S2 is equal to 2 multiplied by 2 times 2, sorry, skipping ahead a little, 2 times 2 minus 3, right? So this is going to give us what? 2 times 4 minus 3. This is going to give us 2. So the sum of the first two terms is equal to 2, which means this over here is equal to 2, -2 plus d. We want to move this -2 to the other side, so d is therefore going to be 4. So now we found the common difference. So we have u1, which is -1, equals -1, and the common difference is equal to 4. Now we can find the other two terms very easily, right? So you start with -1, you add 4, that's going to be 3, you add 4, that's going to be 7. So -1, 3, and 7 are the three consecutive forms in this arithmetic. Oh, sorry, hold on. I made a mistake. It's actually not supposed to be like a normal arithmetic series. It's supposed a sequence is supposed to be a series. So Sn is equal to -1 plus 3 plus 7 plus n. It's ongoing. Okay, good. That's that question. Let's move on. Okay, so now let's tackle these questions over here. Yeah, we have a bunch of different ones and we're just going to go through them. Okay, so find the nth term of each of these sequences, okay? So the first one is going to be 3, 8, 13, 18. Yeah, 13, 18, and it's ongoing. Okay, so for u1, that's already given. u1 is equal to 3, and now d. D, you just take any term and subtract it by the term before it. So 8 minus 3 or 13 minus 8, whatever. So 8 minus 3 is what is going to give us 5. So d is equal to 5. So with that, we can build the nth term very easily. So un is equal to 3 plus n minus 1 times 5, right? Times d. So un is therefore equal to 3 plus 5n minus 5. So un is equal to -2 plus 5n. We'll switch it around. We'll say 5n minus 2. So it looks nicer. So that's the first one. And the answer for that is correct. Okay, let's keep going. We have 101, 97, 93, 89, right? And then it keeps going. So for this sequence, the first term is equal to 101. And d is equal to 4. 101 minus 90, sorry, it's going to be -4. Yeah, -4. Because here the sequence is decreasing. Yeah, so it's going backwards. So -4, because 97 minus 101 is -4. So to build the nth term, we say 101 minus n minus 1 plus, plus n minus 1 times d, which is -4, right? So we're going to have, let's try to, or well, okay, never mind, sorry. So 101 minus 4n plus 4, right? So -4 times -1 is plus 4. So un is equal to 101, 105 minus 4n. So 105 minus 4n, that is correct. Okay, let's go to the next one. We have a minus 3, a plus 1, a minus 3, a plus 1, 1, no, a plus 5, a plus 9, a plus 5, a plus 9. Let me see. Let me make sure that I got that correctly. A minus 3, a plus 1, a plus 5, a plus 9. Okay, good. So a minus 3, a plus 1, a plus 5, a plus 9. Good. So now for this one. The first term we know is a minus 3. Yeah, this is the first term of the whole sequence. Then you have for the common difference. So for the common difference, I'll actually write it out this time. So we say a plus 1 minus a minus 3. Yeah, so we'll do the common terms. We'll say a minus a, and then plus 1 minus 3, so it's 1 plus 3. So the common difference, we therefore get these two cancel out, and then 1 plus 3, so we get the common difference is equal to 4. Good. Common difference is equal to 4. So let's build the nth term sequence. Nth term. Un is equal to a minus 3 plus, I'm going to put this in a bracket, n minus 1 times 4, right? So then this is going to give us a minus 3 plus 4n minus 4, yeah? So this is un is equal to a minus 3 minus 4 plus 4n. What I did is just I moved the minus 4 here so we can visualize it better. So negative 3 minus 4 is negative 7. So a minus 7 plus 4n. And that is 4n plus, yeah, that is correct. Okay, good. Let's move on. The final one, negative 20, negative 5, then 10, and then 25. So this one's interesting because we reduce. Oh no. Okay, no. Never mind, scratch that. So, okay, negative 20, negative 5, 10, and 25. So 25 minus 10, yeah, for the common difference is going to be 15. Yeah, it's the same thing. 10 minus negative 5, that's 10 plus 5, so that's going to be 15. And then u1 is, as always, it's going to be negative 20, the first term here. Good. So the nth term is therefore going to be un is equal to negative 20 plus n minus 1 multiplied by 15. So un is equal to negative 20 plus 15n minus 15. un is equal to minus 20 minus 15 is negative 35 plus 15n. Is that correct? 15n minus 30. Yes. Yeah, we can rewrite it for it to look a little better. So 15n minus 35. Yeah. Okay, cool. So that's for the first question. Now let's move on to the second one. Okay, so the second question says, find the terms indicated in each of these arithmetic sequences. Okay, so we have the sequences given to us, right? And then we have the terms here that they want us to find, yeah? So for the first one, we have 5, 11, 17, and 23. And we're supposed to find the 15th term. Yes, we're supposed to find U15. So how are we supposed to do that? Well, first of all, we note down what U1 is, that's 5. And then the common difference, you can say 11 minus 5. 11 minus 5 is 6, right? Or 17 minus 11 is 6 as well, or 23 minus 17, whatever. Okay, so now you want to find what U15 is. So we're just going to plug in U15 and use these ones. So yeah, this is relatively easy. So plus 15 minus 1, which is 14, multiplied by 6. So U15 is therefore 5 plus, is equal to 5 plus 14 times 6. I'm not sure what that is, so let me use a calculator here. 14 multiplied by 6 is 84. So 5 plus 84 we're going to get is 89. So U15 is equal to 89. Let's check. Yes, that is correct. Okay, let's move on to the next one. We have 10, 3, negative 4. 10, 3, negative 4. And then negative 11, and so on. And we're supposed to find U11. Okay, so U1 is equal to 10, and D is equal to 3 minus 10, that is negative 7. Oops, sorry, is equal to negative 7. Let me plug in my charger. Okay, so negative 7, right? So now, let's just find U11. So you have U11 is equal to 10 plus 11 minus 1, which is 10, multiplied by negative 7, which is going to be negative 7t. So u11 is equal to negative 7t plus 10, which is negative 60. Yeah. So the next one we have negative 60. That is correct. Okay, good. Let's move on to the next one. A plus 2, A plus 4, A plus 6. So A plus 2, A plus 4, A plus 6, and then it keeps going. For this one, we're supposed to find the 17th term. So U17 is equal to what? Okay, so U1 is equal to A, and D is equal to, let's actually calculate it. Let's use these two. A plus 4 minus A plus 2, right? So, I don't even know why. Yeah. So A plus 4 minus A plus 2. So A minus A, and then 4 minus 2. These two cancel. 4 minus 2 is 2. So D, common difference is 2, right? Common difference is 2. So now, U17 is equal to A plus n minus 1, so 16 multiplied by 2. Yeah? So you have U17 is equal to A plus 32. And there. So 32 plus A. Yeah, that matches up. So U17, the 17 term is A plus 32, and that is correct. Okay, good. Next one. 16, 12, 8, 4. 16, 12, 8, 4. And it goes on. And we're supposed to find the n plus 1th term, n plus 1th term. So n is equal to n plus 1. Okay. So simply what we're gonna do is I think we're just going to take, so the n plus 1 term. Okay, so what we're going to do for this one is we're going to replace the un here. So we're going to say un plus 1 and then plug in the information we have. Okay, so let's say we have u1 is equal to 16. And then we're going to say d is equal to 12 minus 16 is negative 4. So you have un plus 1 is equal to 16 plus n minus 1. Yeah, so it's n plus 1. So n is equal to n plus 1, and then that's minus 1. Yeah, so because you're replacing it for n in this case. So it's going to be n, and then you multiply it by negative 4. Okay, so let's simplify this. You have 16 plus n times negative 4. Yeah, so this is going to give you 16 minus 4n. Yeah, and that's that. That's the un plus 1th term. So un plus 1 is equal to 16 minus 4n. That looks like a 9 or n. That is correct. Okay, let's move on to the third question. Okay, so the next question says, find the number of terms in each of these arithmetic sequences. Okay, so we're giving arithmetic sequences, giving you one, and it goes down until the last and final term. Okay, so let's take A. So we have 16, 11, 6, 16, 11, 6, and then dot, 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 negative 64. Okay, so this is our sequence, yeah? Arithmetic sequence. So you have U1 is equal to 16. Then you have D is equal to 11 minus 6, going to give us negative 5, yeah? You see that this sequence is actually descending, yeah? Okay, cool. So then we also have an extra value that we have to use. Oh my goodness. So we have an extra value that we have to use, which is un. So un is equal to what? Negative 64. Okay, so how do we do it? We say un, okay, is equal to 16 plus n minus 1 times negative 5. Okay, expand. So you have un is equal to 16 plus n minus 1. Oh, sorry. You're supposed to say 16 minus 5n plus 5. Now un is equal to negative 64, so I can replace it here and say, and then, yeah, so you replace it here with un. So negative 64 is equal to 16 plus 5, which is 21, minus 5n. Okay, we're going to subtract 21, so it's going to give us negative 85 is equal to 5n. And if you divide by 5, you'll get n is equal to 17. Let's just double check that real quick. And yes, yeah, so n is equal to 17. So you have 17 terms in this sequence. Okay, good. Next one. We have negative 108, negative 101, negative 108. Bless me, thank you. So negative 94, and then dot dot dot, and then we have the final term, which is negative. Oh, it's 60. Sorry, I read the sequence under that. Okay, so u1 is equal to negative 108, and d is equal to what? So we can actually see that this term is ascending. Yeah, so it's going to be a positive. So you have negative 101 minus um negative 108. So negative 101 plus 108, you're going to get wait, what? No, so it's negative 101 minus negative 108. Yeah, so you get 7. So d is equal to 7. And then you have your last term un is equal to 60. Yeah, cool. So now you're gonna say un is equal to u1, which is negative 108, plus n minus 1 times 7. Okay, so un is equal to 60. So 60 is equal to negative 108 plus 7n minus 7. Okay, so we're gonna do that. So we're gonna add 108 and add 7. Yeah, so 60 plus 108 plus 7 is going to give us 175 is equal to 7n. Therefore, n is equal to 25. Let's double check that. That is correct. Okay, good. Move on to the next one. Here we have negative 15, negative 19, negative 15, negative 19, I think negative 23. Yep. 3, then negative 95. Yeah. And we're supposed to, yeah, okay, cool. So first off, we take u1 is equal to negative 15, and then we find d. What is d? So d here, we know that this sequence is descending. So d is going to be a negative number. So d is obviously negative 4. Yeah, cool. So then un is equal to negative 95. All right. So we're just going to straight away write all the values. So we have negative 95 is equal to negative 15 plus n minus 1 times negative 4. Lots of negatives in this one. Negative 95 is equal to negative 15 minus 4n plus 4. Yeah, this is going to give us negative 95 is equal to negative 11 minus 4, 9. So we're going to add 11 to this side and then divide by 4. So we have negative 95 plus 11. That's going to be negative 84 is equal to 4n. And then divide negative 84 by 4. So that's negative 21. Therefore, n is equal to negative 21. We don't have to write the negative. There's just 21 terms. Yeah, so just 21. Okay, cool. And now the last and final one. 2a plus 5, 2a plus 3, 2a plus 1, and then the final term is 2a minus 23. So we can see from this value here that the sequence is descending. So we're going to have a negative common difference. So you have u1 is equal to 2a plus 5. And you have the common difference is equal to 2a plus 3. We can calculate it. Minus 2a plus 5. Yeah? So 2a and 2a are going to cancel out. 3 minus 5 is going to be negative 2. Yeah? So the common difference is equal to negative 2. Good. Then un is going to equal to 2a minus 23. Yeah? So now let's build our let's find the total. Oh my god, what are we finding again? We are finding the number of terms. Sorry. Yeah. So we have 2a minus 23 is equal to u1, which is 2a plus 5, minus plus n minus 1 times negative 2. Good. So here we have 2a plus minus 23 is equal to, now we're gonna do 2a plus 5, and then minus 2n plus 2. Yeah? So now what are we gonna do? We can subtract 2a from both sides. So minus 2a and minus 2a. So these will go. So you are left with negative 23 is equal to 5 minus 2n plus 2. So then you have, this is plus 2, so negative 23 is equal to 7 minus 2n. And then I subtract 7, so that's going to be negative 30 is equal to negative 2n. And then therefore n is going to equal to 15, which is correct. Okay, cool. Let's move on to the next question. Okay, so the next question says determine the first term and the common difference of the arithmetic sequences that are generated by each of the following nth terms. So what I'm thinking we're going to do is we're going to find u1 and u2. So this is the first term that they want, and u2 so that we can subtract u2 from u1 to find the common difference. So un is equal to 5n minus 7. un is equal to 5n minus 7. Okay. So first of all, the first term. So that's going to be 5 times 1, which is 5, minus 7 is going to give us negative 2. So u1 is equal to negative 2. We do the same thing. u2 is equal to 5 times 2, which is 10. 10 minus 7 is equal to 3. So u2. So 3 minus negative 2 is going to give us 3 plus 2, which is 5. So the common difference is therefore 5, and that is correct. Okay, cool. Move on to the next one. We have un is equal to 3n plus 11. un equal to 3n plus 11. By the way, you can feel free to just pause the video and solve on your own and then check with me. So it's up to you how you deal with that. But thought I should just say it. Oh my god. Okay, so u1 is equal to 3 times 1, which is 3 plus 11. Is going to give us u1 is equal to 14. Then I have u2. That's going to be 3 times 2, which is 6, plus 11, which is going to be 17. So u2 is equal to 17. The common difference is equal to 17 minus 14, which is 3. So the common difference is therefore 3. So u1 is 14. Common difference is 3. That is correct. Let's keep going. We then have un is equal to 6 minus 11n. So un equal to 6 minus 11n. Okay, so say u1 is equal to 6 minus 11 times 1, which is just 11. That's going to give us u1 is equal to 6 minus 11. 4, 1, so it's negative 5. Then for the common difference, we're going to do u2 first. So 6 minus 11 times 2, so that's 22. So u2 is equal to 6 minus 22. So 6 minus 22 is negative 16. Yeah, so u2 is equal to negative 16. And then from u1 to u2, so we do negative 16 minus negative 5, so it's just going to be plus 5, which is going to be negative 11. Yeah, so d is equal to negative 11. Okay, cool. Next one. We have un is equal to 2a, I believe. All right, 2a plus 2n plus 1. Okay, so u1 is equal to 2a plus 2 times 1 plus 1, which is just 3. Okay, then u2 is equal to 2a plus 2 times 2, which is 4, plus 1, which is 5. So 2a plus 5. And to find the common difference, we say 2a plus 5 minus 2a plus 3. Right? So the 2a and 2a is going to cancel out. 5 minus 3 is going to give us the common difference is equal to 2, which is also correct. Okay, next question. Okay, So the next question says the sixth term of an arithmetic sequence is 37. So let's write that. So U6 is equal to 37. And the common difference is 7. So D is equal to 7. Okay. Find the first term and the nth term. So we need to find U1, and we need to find UN. Okay, so I have U6 and a common difference. So first, we can try to find U1 by plugging U6 into our formula UN with the common difference. So you have U6 is equal to U1 plus 6 minus 1 multiplied by 7, right? So you have U6 is equal to 37 is equal to U1 plus, this is going to be 5 times 7, so plus 35, right? So we do 37 minus 35, that's going to give us 2. So U1 is equal to, no, wait, 37 minus 35, yeah, is equal to 2. But here it says that it's negative 2. Oh, no, sorry, I'm looking at the wrong answers. Yeah, okay, so U1 is equal to 2. That is correct. Now, so we have U1 now, now we can do UN, so, or find UN, so UN is equal to U1, which is 2, plus n minus 1 multiplied by 7. So here you have UN is equal to 2 plus 7n minus 7. So UN is equal to 2 minus 7, that's going to be negative 5 plus 7n. Yeah, so then we can take UN is equal to 7n minus 5, rearrange it so it can look nicer. And that is correct. Okay, let's move on to the next one. We are given that the fifth term of an arithmetic sequence is 0, and the 15th term is 180. Okay, so the fifth term, U5, is equal to 0. And that the 15th term is equal to 180. Find the common difference in the first term. Okay, so D and U1. Okay, so as I said before, we did a question like this, similar to this. When the two most important elements, which are D and U1, are missing from your arithmetic sequence question, and you need to find them, whatever information is given to you is probably going to be so that you can build a system of equations. Yeah, so you have U5 is equal to 0 and U15 is equal to 180. So we just plug these in. So you have U5 is equal to U1 plus 5 minus 1, which is 4, multiplied by D, right? So that's equal to what? U1 plus 4D is equal to 0. So this is my first equation, right? And then here on the side, you have you have U15 is equal to U1 plus n minus 1, so 14D, right? And U15 is 180, so you have 180 is equal to U1 plus 14D. And that is your second equation, right? So you write these under each other. So you say U1 plus 4D is equal to 0. And you say U1 plus 14D is equal to 180. Okay? So now you do system of equations. You can subtract these two, because then that will cancel out both U1s. 4 minus 14, that's going to be negative 10D. 0 minus 180, that's going to be negative 180. So D is equal to 18. Yeah? So in this case, D is equal to 18. Good. So now that you have D, pick the whatever simpler one is here. So I'll take this equation, yeah, and I'll say U1 plus 4 times 18, because it's 4 times D, is equal to 0. Okay, 4 times 18 is what? Let's see, sorry. 4 times 18 is 72. So U1 plus 72 is equal to 0. So you just move the 72 to the other side, and therefore we get U1 is equal to negative 72. Cool, let's move on to the next one. Okay, so moving on to the next question. The sum of three consecutive terms of an arithmetic sequence is 24, and their product is negative 640. Find the three numbers. Okay, so we did a question similar to this in the video, so earlier this video. So we did U minus D, U and U plus D. Yeah, this is probably the best form that you can have for three consecutive terms when you don't know what they are and you need to work out for them and you have a sum and product. Yeah, so this is the best, simplest form that you can probably go for. Okay, so you have U minus D, U and U plus D. So u minus d plus u plus u plus d is equal to 30, correct? Is equal to, 24, sorry. To 20, 24. Okay, so simplifying this is going to simplify to what? You have u plus u, which is 3u, negative d plus d, which is just nothing. So you have 3u is equal to 24. Yeah, u is therefore going to be 8. Yeah, so you already found your first term, the one term in the middle. So now you have u minus d multiplied by u multiplied by u plus d is going to give you negative 640. Yes. Okay. Cool. So for this one, we'll multiply this term by that term, okay, and keep the u on the outside because we already have u, right? So u squared minus d squared all multiplied by u is equal to negative 640. This is what we're going to get if we expand these two. And yeah. Okay, so now we're gonna before we sub in u, we're gonna divide both sides by u. So this is gonna be divided by u, and this is gonna be divided by u. These two are gonna cancel out. So you have u squared minus d squared is equal to negative 640 divided by u. Okay? So u is what? U is equal to 8. So we're gonna replace u now in the equation. So you have 8 squared minus d squared is equal to negative 640 divided by 8. So now let's actually work for it. So you have 64 minus d squared is equal to negative 640 divided by 8 is negative 80. Yeah? Now you're going to minus 64, so you're going to have negative 144. Multiply both sides by negative 1, so you get d squared is 144. Take the square root, you're going to get d is plus or minus 12. Yeah? So because d is plus or minus 12 and u is equal to 8, that means our middle term is 8. The term before that is negative 4, and the term after is 20. Yeah, so negative 4, 8, and 20, and that is correct. Okay, next question. Okay, so the next question is not really a question for it's not testing arithmetic or geometric sequences as much, or not really at all, to be honest. It's just a general logical financial question, okay? So Jung Ho earned 38,000 when he started his first job in the year 2000, okay? So in 2000, oh my goodness. So in the year 2000, he had how much? 38,000. He had 38,000, let's assume dollars, okay? Oh, it's euros. So, yeah, 38,000 euros. Okay? He received a raise of 500 euros each consecutive year. Determine how much he earned in 2017. Okay, so in 2017, all right. So from 2000 to 2017, how many years is that? That's 17 years, right? So 17 years. So for 17 years, every single year he kept on receiving 500 euros, 500 euro raise, right? So how do we calculate that? We say 17, right, multiplied by 5, which is equal to 17 multiplied by 5 is 85. Yeah, so we're assuming, well, it's times 500, so it's 800. Yeah, so not 800, 17,000 multiplied by 500 is 8,500. There we go. So it's 8,500 euros. Yeah. So then we add this 8,500 euros to the initial amount, which is 38,000. So you have 38,000 plus 8,500. So 0, 0, 5, 8 and 8 is 16, and then there we go. So his salary then in 2017 is equal to 46,500 euros. Yeah, and that is correct. Now, the next part of the question. Determine how much he earned in 2000, sorry, evaluate in which year he would earn 50% more than his original salary for the first time. So 50% more than his original salary. That means that we can take the half of 38,000, right? So we take 38,000 and divide it by 2. And that's going to give us 19,000. Okay? So we have 19,000. So you take 38,000 and you add 19,000 to it. Okay? 0, 0, 0, 8 and 9 is 17, and this is 5. So we need to see how many years it took him after 2017, okay, for him to reach this salary, yeah, 57,000. Okay? So, what are we doing? We're starting at 2017. So we are going to do, let's think. So we're starting at what? 38,000, right? Because it says here, and then his original salary for the first time. Yes. So you have 38,000, right? Plus n times 500, right? Is equal to or greater than 57,000. Okay? So why? We start at the 38,000 euros, okay? And then we add to that every year, so this n stands for how many years it is, times 500. Yeah, so every year he's gaining 500. So that means every year plus 500, plus 500, plus 500. So we're seeing that how many years n will he have to, like, pass with 500, with him making 500 each month, plus the 38,000 that he was doing in the beginning, to equal to or to get higher than or equal to 57,000 euros. Okay? So we just solve for n. So first of all, we're going to take, sorry, it's going to be n times 500 is greater than or equal to 57,000 minus 38,000. Okay? So 57,000 minus 38,000. That's going to be 19,000. So yeah, so we have 9 times 500 is greater than or equal to 19,000. Then we divide by 500, so n is greater than or equal to 19,000 divided by 500, and that is going to give us 38. Yeah? So the amount of years that it took him would then be what? So he started, he had 38,000 in the year 2000. So you add 38 to the year 2000, so then that means that he has 57,000 euros in the year 2038, which is correct. Okay, let's move on. Okay, so now let's do the second one. So we have 31 plus 40 plus 49. I'm writing it with commas, I just realized. Plus 517. Okay, cool. So, first of all, U1. So U1, my first term is 31. And then my nth term is 517. And then my common difference is 9, right? So 40 minus 31 is 9, 49 minus 40, and so on. Okay, so to find the amount of terms, right? So we're going to say un is equal to u1, which is 31, plus n minus 1 times 9. So then you have un is equal to 31 plus 9n minus 9. So you have un is equal to 9n minus 6. And then you replace un we have 517. Oop. 517 is equal to 9n minus 6. So we add 6, that's going to give us 523 divided by is equal to 9n, right? So let's see, 523 divided by 9. That is not true. Okay. 31. 40. 31. 9n minus 9. 3 minus 9. Negative 6. Add 6. 517 plus 6 is 523. 523 divided by 9. 50. Not it. P is on. Oh. Ah. Okay. So yeah, this is the sequence from the second question. So we're gonna just keep going. So we have U1 is equal to 31. We have UN is equal to 517, and we have D is equal to 9, right? So we're gonna find the number of terms first. So you have UN is equal to U1, which is 31, plus n minus 1 multiplied by 9, right? So you have that is equal to 31 plus 9n minus 9. So 31, sorry, yeah, 31 minus 9 is going to be 22 plus 9n, right? And un is equal to 517, so it's 517, 517, right? So we'll do 517 minus 22, which is equal to 495. 495 is equal to 9n. We divide 495 by 9, and that's going to give us 55. So n is equal to 55. That means that in this series right here, we have in total 55 terms. Okay? So that means that we are summing these 55 terms. So S55 is equal to 55 divided by 2 multiplied by 31 plus 517. Okay? So 55 over 2, we're going to leave that as is, and multiply, so add the 31 to the 517. That's going to be 548. Yeah? Those two multiplied by each other, so 55 over 2 multiplied by 548. That's going to give us 15,070. Yep. So that's 55. The sum of the 55 terms in this series is 15,070, which is correct. Okay, cool. Now the next one. So the next one is a minus 1 plus, so a minus 1 plus a plus 2, or is it minus 2? A plus 2, um, a minus 5, a plus 5, sorry. And then dot dot dot. Then your, so plus dot dot dot. And then your last term is a plus 146. There we go. Okay, so, all right. So, yeah, so U1 is going to be a minus 1. Um, UN is equal to a plus 146. And then D is equal to, you can say that minus that. So it's going to be, so yeah, if you minus these two from each other, A's will cancel. Minus 1, minus 2, so it's going to be negative. No, it should be just 3. 2 minus my, oh yeah, so 3. There we go. So now let's find the amount of terms first. So you have UN is equal to U1, which is A minus 1, plus N minus 1 multiplied by the common difference 3. Right? So this is going to be a minus 1, sorry. A minus 1. UN is equal to a plus 146. So a minus 1 plus 3 minus 3, right? So then you have, we can subtract a from both sides. So you can cancel these two out. So you have 146 is equal to negative 1 plus 3n minus 3. I have to put the n here. So minus 1 minus 3 is minus 4. Added here, you're going to have 150. So 150 divided by 3n, n is equal to 50. Yeah, so there's 50 terms in total. That means that we're summing 50 terms. So S50 is equal to a minus 1. No, sorry. So it's n over, so 50 divided by 2, so we can say just 25. Yeah. So 25 multiplied by a minus 1, right? Plus a plus 146. Okay. So how much is that going to be? So you have 25 multiplied by a plus a minus 1 plus 146, right? So you have this is going to be 25 multiplied by 2a plus 145, right? And then that is multiplied by all of that. So you have 25 multiplied by 2, so 50a. So you have 50a, and then 25 by 145, so 25, 145. 5 times 5 is 25. 5 times 4 is 20, that's 22. 5 times 1 is 5 plus 2 is 7. Then you have 0. 2 times 5 is 10. 2 times 4 is 8 plus 1 is 9. 2 times 1 is 2. Then you're going to have 5, 2, 9, and 7. That's 16, 3. So 3,625. So 50A plus 3,625. And that is the correct answer as well. Okay, let's move on to the next question then. Okay, so now let's go on to the next question. So over here it says find the value of each of the following sums. Okay, so let's look at A first. So I have the sigma notation, you have 50, you have R is equal to 1, and then you have 3R minus 8. That is the pattern that the sequence follows. So this is where we're starting. We start at U1, and this is our nth term, so it has this, so this is U50, this is U1, so that means that the sequence that we're following, or the series that we're following, starts at U1, yeah, so starts, and it stops at U50, yeah. Cool. So, to find the sum of all these terms, we do Sn is equal to n over 2 multiplied by u1 plus un, right? But we don't actually know what u1 and un are, yeah? We know that this is like this talks about this is, hinting at the 50th term, and this is hinting at the first term, but we don't know what they actually are. So we're going to use this nice little guy over here in order to find out, yeah? So we're going to say un, or well, in this case, u1 is equal to 3 times 1 minus 8. So 3 minus 8 is going to be negative 5. So that's u1. And then for u50, we have 3 times 50 minus 8. Yeah, so we have 3 times 50 is 150. 150 minus 8 is 142. So now we can build our equation. We say Sn, or well, S50, sorry, because it's the sum of the 50 terms. Yeah, so S50 is equal to 50 divided by 2, multiplied by u1, which is negative 5, plus 142, right? So this is going to simplify to 25 multiplied by 137, right? So 137. So 137 multiplied by 25. Let's see what that gives us. So 5 times 7 is 35. 5 times 3 is 15 plus 3 is 18. 5 times 1 is 5 plus 1 is 600. We have 0. 2 times 7 is 14. 2 times 3 is 6 plus 1 is 7. And then 2 times 1 is just 2, right? So then it's just 2. So you have 5. 4 plus 8 is 12. 7 plus 7 is 14. So therefore you get 3,425. 1,425. I don't know why I did it this way. Could have just used a calculator. 3,425. So that is the sum of S50. So this is how much this expression comes out to be. And that is correct. Okay, next one. We have B, so we have sigma notation, 100 and R equals 1. So you have sigma notation, it goes to 100, starts at R equals 1, and we have 7 minus 8R. 7 minus 8R. So this is our expression that we're following. Okay, so just like the last one, we'll find the U1, UN, and then actually move on. So you have U1 is equal to 7 minus 8, right? Because 8 times 1 is just that. So this is going to equal to what? Negative 1. So U1 is equal to negative 1. Then you have U100. So it's going to be 7 minus 800, right? Because it's 8 times 100, which is 800. So 7 minus 800 is negative 793. Yeah, so U100, oops, U100 is equal to negative 793. Okay, good. So now we do S100 is equal to 100 divided by 2 multiplied by negative 1 minus 793, right? It would usually be plus, but because of the negative, it's just going to be turned into a sign, minus sign. They have 50 multiplied by 1 minus all of that is going to be negative 794, right? And okay, this one I'm definitely just going to do a calculator. So you have 50 multiplied by 794. So that is equal to negative 39,700. So that is the sum, and that is correct. Okay, now for the next one, final one. right? Yes, so the phi normal. We have 20 r equals 1, so sigma notation, got better. So 20, r is equal to 1. 2ar minus 1 multiplied. Okay, so now we find u1 first and n, which is u20, sorry. So u1. So u1 is 2a times 1 minus 1. So this is u1. And then u20 is equal to 2a times 20. That's 40a minus 1. Okay? And then we're going to then say Sn, or well, S20, sorry. So S20 is equal to 20 divided by n multiplied by 2a minus 1 added to 40a minus 1. Okay? So this is going to simplify to, it's 20 divided by 2. Yeah? So this is going to give me 10. And this is going to multiply 2. So we can say 2a, I didn't write the a here. So 2a plus 40a minus 1 minus 1, close bracket. This is going to equal to 10 times 2a plus 4a is 42a, minus 1 is negative 2, then multiplied by 10 for both of them. So you have 420a and then negative 20. So 420a minus 20. And that is correct. Yeah, so the sum of the first 20 terms is this right here. Okay, cool. All right. Let's see what we will do next.